Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're just going to go through some questions and problems involving lines in the XY plane. It's going to be a riot. Let's have some fun. Okay, so this first problem here is going to be a nice and simple one. It goes, a line has equation 3y minus 5x equals 2. Okay, let's remind ourselves about what that means. That means that we have a line in the XY coordinate system, and that for every single point, x and y, that's on the line, they all satisfy the equation where 3 times the y coordinate minus 5 times the x coordinate happens to equal 2. And our first challenge is to find its gradient and its y-intercept. And remember that you can only see the gradient and the y-intercept from the equation if you've got it in the form y equals blah 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 blah. So let's do that. So first of all, we're going to have to rearrange to make y the subject. So let's move the 5x over. So we get 3y equals 5x plus 2, and then divide by 3 on both sides. And we get the y equals 5 over 3x plus 2 over 3. Boom, wasn't that easy? I mean, now we can just read off that the gradient is 5/3 and the y-intercept is 2/3. And let's remember that the gradient is kind of a measure of how steep the line is. We've got 5/3 here as our gradient, so it's a positive number a bit bigger than 1. So it's going to be a relatively steep line, and it intercepts the y-axis at y equals 2 over 3. We're getting a nice little feel for what our lovely little friend of a line looks like. Anyway, so next question. Let me just rub this bit out. Okay, so our next bit is to deduce whether the line passes through the point 2, 4. So how are we going to think about this? Remember that for the point 2, 4 to even be on the line, it must satisfy the x and y coordinates of this point must satisfy this equation. So let's just check if that happens. I.e., if we plug in 4 and 2, we hope that when we put it through this here, that it equals 2. If it doesn't equal 2, it can't be on the line, because it doesn't satisfy the equation. Anyway, so let's check. 3 times 4 minus 5 times 2. That's 12 minus 10, which equals 2. So yes, in fact, the point 2, 4 does in fact lie on the line. That was an easy one. Let's do something slightly harder. Okay, so this next one is a little bit trickier. It goes like this. A line passes through the points 1, 10 and 3, 2, and we're tasked with finding its equation. Now, to find the equation of a line, we're going to need to find its gradient and its y-intercept so we can set up the equation y equals mx plus c. But how are we going to find the gradient and the y-intercept? That seems quite difficult. Well, let's literally draw out this problem in the xy plane. Let's plot these points, get a feel for what our line looks like, and then we can find out. Anyway, so let's do that. So if we just draw a nice little x and y axes, point 1, 10, that's going to be 1, 10 all the way up here, and 3, 2 is going to be like that. So our line looks something like this. That is a horrible line, not very straight at all, but anyway, let's take some notes. It's got a negative gradient because it's sloping that way, as you would know if you've seen my last video. And it also has a positive y-intercept, which you can clearly see on the diagram. So, if you recall, we can calculate the gradient by making any single triangle here and doing y divided by x to get the gradient. So, we can do this triangle here, connecting the 2 points we already know about, 1, 10 and 3, 2. And then just by looking at the coordinates, we can calculate here, this y value and this x value, divide them and get the gradient. Okay, anyway, so here we drop from 10 to 2, so y here changes by -8, hope you can see that, and x goes from 1 to 3, so it changes by 2. And this gives us some good hope, because when we divide these two values, we're going to get a negative number, which is what we expect. So anyway, you do -8 over 2, you get that the gradient equals -4. Fantastic. And the y-intercept, how are we going to find the y-intercept? Well, we can set up the equation y equals -4x plus c, and then input these coordinates into that equation and then solve for c. I'll show you what I mean. So we can set up y equals -4x plus c, but we know that this and this point must satisfy this equation, so let's chuck these values in and then solve for what c must be. Let's use 3, 2, nicer numbers. So we get that 2 needs to equal -4 times 3 plus c. This quite easy equation, you get that c equals 14. So in other words, we have our y-intercept and our gradient, which means we can form the equation of this line, which is y equals -4x plus 14. Very nice. And we see that we've got a very positive y-intercept, which is what we expect, and we've got a negative gradient, which is also what we you expect. Fan-dabby-dozy. On to the next one. Okay, so this one's a bit more of a thinky kind of question where you have to use your brain a bit. It goes, a line has equation y equals mx plus c, so basically any possible line. And our first task is to find an expression for the x-intercept. Well, what does the x-intercept mean? That's when the line crosses the x-axis. And can we think of any special properties that point must have? Well, if the line were to touch across the x-axis, the y-coordinate at that point must be 0. So what we can do is set y equal to 0 and then solve for what x has to be, and then we'll get the x-coordinate of the y-intercept. And then our part B is, without referring to part A, explain why increasing the y-intercept will make the x-intercept more negative, assuming the line has a positive gradient. Now, I don't have a huge amount of space, so I'm going to do this on the next board. Let's go. Okay, so firstly, we're just going to take y equals mx plus c and sub in y equals 0 and see what we get. So, in other words, we have 0 equals m times the x-intercept plus c. Rearranging, we get that the x-intercept must equal negative c divided by m. So negative the y-intercept divided by the gradient. Now, isn't that wonderful? That's our answer to part A. Now, our part B asked us to explain that if we increase the y-intercept and the gradient is, and we have our own line which is a positive gradient, why that should increase the make the x-intercept more negative, but we can't refer to the equation we just derived. Well, let's do that anyway. Let's refer to this equation just to gut check this, right? So if, assuming that m is positive, and then this will still be a negative number, and if we increase the y-intercept, because it's on the top of this fraction, it will also increase the x-coordinate. But since we've got a negative number here, and increasing this will make it more negative. But why should that make sense, like, without referring to that? Well, let's draw a diagram. So we have a line here with a positive gradient and a positive y-intercept. Looks like that. Now, what happens when we increase this y-intercept? If we make it increase the y-intercept, we're shifting the graph up, and therefore it shifts up and it sweeps a bit further along the negative x-axis, and it makes the x-intercept more negative. So that was just a bit of an intuition question, I think. I liked that a bit. Anyway, all of those 3 questions, I hope, should have been pretty easy for you guys. You probably did a lot of that in GCSE. Anyway, that will be it for this video. Thank you very much for watching Maths with Hamblin, and I'll see you in the next one. Bye-bye.